refraction says that first law is incident ray, reflected ray, and the normal drawn are lies in the same plane. Second law, that is Snell's law, that is n1 sin theta 1 is equals to n2 sin theta 2, where n1 and 2 are the refractive indices of medium 1 and medium 2. So actually in this experiment we will verify second law, that is Snell's law. Okay, for that purpose this is some kind of glass slab. So first I have fixed this thing so that it will not, okay, इधर उधर नहीं हिलेगा, okay, so it will not disturb, that's why we have fixed it. Next thing, we will mark the position of this glass slab so that we will remove it after some time and we will again replace it. That's why I am marking it. Okay, so this is the mark for this glass slab. Okay, so next I will choose a point. Let's say this one is point. I will draw some normal here. Okay, so for normal I will use the protector. The normal is, okay, so yeah, this one is your, so this point. I will join this point. This is your normal. I will draw some dotted line. I will let you later explain why I am taking the dotted line. Okay, so this is the normal here. I will choose some angle, that is called incidence angle. Let's say for the time being I am choosing the incidence angle, that is 30 degree. Okay, so zoom it, 30 degree, 10, 20, 30. Okay, so my incidence angle is 30 degree. So I will, this is my incident ray, and this angle with this normal is 30 degree. Okay, so this is, let's say it is your incidence. Next I will fix some pin there. Okay. One more thing you should remember, that the distance between these two pins, you can use more than 2, so the distance between these two pins should be more than 5 centimeters so that you can avoid any kind of error. Okay, so I will see the reflection of these pins using this glass slab. Okay, so next I will put this glass slab again. In earlier I have marked some, okay, so that I can fix it again with this place. So I have fixed. Oh, one more thing, sorry, I made a mistake to mention. So I will extrapolate these lines. Okay, I will extrapolate this line. So if these glass slabs are not there, so it will follow this part. Again we are using some kind of dotted line to distinguish it from this rays. The line without dotted, that is continuous line, it indicates the ray, okay, the path that is actually taking the ray, and the dotted line we are some kind of normal or some kind of ray, that is if it is not there. To distinguish this ray and this imaginary part, I am using some kind of dotted line and this continuous line. Okay, so next I will put this thing. Next I am putting this again in its previous position. Okay, so now you can see from zoom here. Now you can see, okay, so you can see some kind of refraction, that is this point. Okay, so you can see some kind of refraction of this of these two pins that I am using. Now the refracting surfaces are not very clear, that's why it is some kind of hazy. So I will try to fix the pin. Okay. So I will fix the pin in such a way so that these two pins, there are some kind of refractions are there. I will fix the pins in such a way so that I cannot see this thing, or these pins I will put 2 pins here also, so that these 4 pins will be in a straight line. Actually, in order to draw a straight line, at least 2 points are required. That's why I am fixing 2 points here, and I will also put pin, okay, using this so that it will be a completely straight line. So let me fix. Okay, I have already fixed one pin, so I will fix another one so that the refraction of this pin and this one, and I will fix in such a way so that all lies in a same plane. Sorry, all lies in a straight line. Okay, so let me fix. Yeah, these are the points. Next, I will mark them so that I will not get any confusion. Okay, so these are the 2 points after refraction. Next, I will join this. Okay, I will join this. I will join these points. Okay, so these points will cut this refracting surface at a point. Okay, so this is the point. Okay, so this is my refracting ray. Okay, so one can use this principle also. If I do correctly, this line and this line will be a parallel line. In my case, I have done some mistakes, that's why it is not exactly parallel, but it seems parallel. Okay, so if you do carefully, if you fix this pin carefully, you get a parallel line. Okay, so next thing, I will join these points and these points. So let me join. Again, I am using continuous line. Okay, so next I will draw here again a normal. Let me use protector so that no mistakes will be there. So this one, again some kind of dotted line. Okay, so this is your incidence angle, that is I am fixing it, that is 30 degree, and your this one is your refraction angle. So let me check what is the value of this refraction angle. Okay, so refraction angle, so zoom it, look carefully, that is your 10 and it is your 15, 16, 17 degree. Okay, so your angle of refraction is 17 degree. So this is the one part. So next thing what I will do, I will fix it another incidence angle, and I will do the same, I will repeat the experiment. Okay, same thing. So I will get another refraction angle. Okay, so I will repeat it at least 3 or 4 times. Next thing what I will do, I will make a table, that is incidence angle, that is refraction angle. Okay, incidence angle, refraction angle, sine of incidence angle, sine of refraction angle. Okay, so let's say it is 1, 2, 3, 4. I got 1, 2, 3, 4 some kind of data I will get. Next thing what I will do, I will draw some kind of graph. Some kind of graph of what versus what, that is dependent variable versus independent. So your dependent is that is sine of r. So I will draw a graph sine of r along y-axis and sine of I along x-axis. So let's say they are some kind of point. Okay, so let's say, so next thing what I will do, I will join them. I will join them in such a way in such a way that all the points are not very far and all the points are not very close. That is, in between this, I will join them in such a way. Okay, so if it is a straight line, that means, so I made a mistake, it should be like this. Okay, so if it is straight line means what? Straight line means what? Sine of r is proportional to sine of I, or sine of r is some kind of constant of sine I. You will get some kind of equation. Okay, so if you get a straight line, that means your Snell's law is verified here. Snell's law, what does Snell's law says? Snell's law says n1 sine I is equals to n2 sine r. Here, suppose it is your n1, this is your n2. So n1 sine I is equals to n2 sine r. So if it is a straight line, the graph, if straight line, that means your Snell's law is verified here. And from this equation of this graph, you can find out what is the refractive index of this material. Okay, so let's say your sine r, from this equation I can write sine r is equals to n1 by n2 into sine I. Okay, so your slope, sine r versus sine I, slope will be n1 by n2. So your slope is n1 by n2. Okay, so from this slope you can find out what is the refractive index. Okay, so refractive index of this material. So that's all about your verification of laws of refraction, that is Snell's law. Okay.